Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have another topic, that is 4.6, absolute potential energy. Okay, how we can define it? Uh, the work done, look at the definition. The work done on a mass against the total gravitational field, and remember the last limit of gravitational field is infinity, so I write it in the bracket as up to infinity, is called absolute gravitational potential energy. Absolute gravitational potential energy. So it means that when we perform work on a body against the total gravitational field, total gravitational mean up to infinity. So this work done is called absolute gravitational potential energy. Okay. One is the gravitational potential energy. Gravitational potential energy. This is also called relative potential energy. So it is the work done. It is the work done on a body. Let me write it down. The work done on a body against the gravity is called gravitational potential energy. It is the work done on a body against the gravity is called gravitational potential energy. But what is absolute? Absolute mean work done against the total gravitational field. Total gravitational field means up to infinity. When we perform work up to infinity, that is called absolute gravitational potential. But simply gravitational potential energy means the work done on the mass against the gravity, means this is the work done within the gravity of the earth, and this is the work done beyond the gravity of the earth. Okay, now let us consider we have this is the earth, so the mass of the earth is capital M, this is the radius of earth, capital R, and this is the mass lying at the surface of the earth. Okay, now I want to perform some work, so I want to apply a force on a body, and it cover displacement del r up. So the displacement is covering up and the gravitational force is down. We know that gravitational force is always down. So this mass reaches to r1. This mass reaches to r1. So I apply the force and it cover displacement. So it reaches to r1. So I did some work but against the gravity. I performed some work but it is against the gravity. So work done is defined as force into displacement. Force into displacement. And this force is actually downward and the displacement is upward. Gravity force is always downward and here the displacement is covering upward. So if I remove the dot, I'll place cos theta, but theta will be 180 degree. So this work done is minus f del r because cos 180 is minus 1. Okay. And this force is actually the gravitational force. And the formula for the gravitational force is minus g mm divided by r square. This is gravitational force. Okay. F is equal to m1 m2, g is equal to, f is equal to g m1 m2 divided by r square. Capital M shows the mass of earth, small m shows the mass of body. Okay, look at this distance. Initially the distance was smaller, which is the radius of earth. Now the distance is very large, r1. So it means that the distance is changing. If the distance is changing, so we have to take the average of this distance. So I should take the average of this distance. Okay, so this is r average square. Now this label is equation number 1. This label is equation number 1. Okay, now what is del r? Del r mean final minus initial. Final distance is r1, initial was r, capital R. Okay, so final distance is r1 and the initial was capital R. Okay, shift capital R on the left hand side, so it will be del r plus r is equal to r1. This is the value of r1. So we found the value of r1 here. Okay, now what is the definition of average? Average, the definition of average is sum of the quantities divided by number of the quantities. So there are two distances, one is the capital R, one is the R1. So sum of these distance divided by 2. Okay, what is the value of R1? We know that del R plus R. So putting this value here, so it will be del R plus R divided by 2. Okay, now R plus R is 2R. Yes, R plus R is 2R. Okay, so we got the average as del R plus del R, no 2R divided by 2. Okay, but look at the formula. In the formula there is a square on the average, so we should take the square of this average. So taking square on both sides, so if you take the square, so it is a formula, become a formula a plus b whole square, a plus b whole square. So it is a square plus b square plus 2ab. This becomes a formula a plus b whole square. So a plus b whole square is equal to a square plus b square plus 2ab. Okay, look at this term del r. Del r means the small displacement. Del r means the small displacement. So suppose if we have a smaller number 0.1. 0.1 is a small number. So if you take the square of this small number, it will become more smaller. It will become more smaller. It means that when you take the square or cube of a smaller number, it will become more smaller, means it can be neglected. It is as much as smaller that it is not affecting any figure. So it means that it is very very small, so which is negligible. So that is we ignore this term. So we will have 4r square plus 4r del r divided by 4. Okay, take 4 as a common, so r square plus r into del r divided by 4. So 4 will be cancelled here, and we know that the value of del r is equal to final minus initial. This is the value of del r. So final minus initial, putting this value here, so it will be r square plus r into final minus initial. Okay, now multiply this r inside. So if you multiply this r inside, so what we will get? Look, r square plus r1 minus r square. So r square will be cancelled. So this is the value of r average square. So we got the value of r average square. Okay, this is the value of r average square. Now putting this value in equation number 1, putting this value in equation number 1. Okay, so if you put this value in equation number 1, look what we will get. What is equation number 1? Equation number 1 is W1 is equal to minus GMM divided by R average square into delta R. Okay, putting these values in equation number 1, so what will we have? R1, the value of R average square is R1, and what is displacement? Final minus initial. Okay, now look at these terms. These terms are constant terms. These terms are constant terms. So take it aside. So minus GMM is placed at a side, minus R1 minus R divided by R1. Okay, Now split the LCM. What we will have, look, split this LCM, write this denominator in look at R1 divided by RR1. So if you split the LCM, we will have R1 divided by RR1 minus R divided by RR1. Okay. Now what will be cancelled? R1 and R1 will be cancelled. RR will be cancelled here. So we will get minus GMM 1 over R minus 1 over R1. Okay. Now this is the first work done. We found this is the first work done. This work done is from capital R to this R1. Okay, look at the diagram. Look at the diagram. In the diagram, the body was initially placed at a distance approximately equal to radius of Earth. Then we displaced the body up to a distance of R1. So we did some work. That work done is the first work done, W1. Now we want to do more work. So further you apply the force, it will cover displacement. So this is called second work done, W2. So what is the second work done? The displacement from R1 to R2. So look at the second work done. The second work done will be, I'll write it here. The second work done will be minus GMM 1 over R1 minus 1 over R2. This is the second work done. The second work done is from R1 to R2. The second work done is from R1 to R2. Okay. Now I want to do more work. So I'll displace this mass up to R3. So this is the third work done, W3. This is the third work done. I apply the force and cover displacement against the gravity. This is called the third work done. Okay. Look at the third work done. Third work done will be W3 is equal to minus GMM 1 over R2 to 1 over R3. This is the third work done. Okay. Now I'm going to displace this mass up to N. This is Rn. What is this N? This N is a point inside the gravity. Okay. This is the final distance. So what is a step back from the Rn? A step back is Rn minus 1. Okay. So if want to do a last work done will be from Rn minus 1 to Rn. So this is called Wn. This is the last work done, Wn, from Rn minus 1 to Rn. So this is the last work done. Wn is equal to GMM 1 over Rn minus 1 to 1 over Rn. This is the last work. Look at the diagram. Suppose the body is placed at Rn minus 1. So we will apply the force and curl the displacement and it will reach us to Rn. So this is the last work done, which is Wn. Okay. Now we found all the work done. Now I want to find the total work done. I want to find the total work done from distance R to Rn. I draw this line. This line shows the limit of the gravity, suppose. So if I want to find the total work done from R distance to Rn, so I will have to sum of all the work done. So for the total work, I should add all those works. Okay. So I am adding all these work done with one another. What is the first work done? Putting the value of first work done, which is minus GMM 1 over R minus 1 over R1. Second work done is minus GMM 1 over R1 minus 1 over R2. Third work done is minus GMM 1 over R2 to 1 over R3 up to last work done is minus GMM 1 over Rn minus 1 to 1 over Rn. Okay. These are the values of work done. So I put it all the values of work done here. Okay. Now what should be taken as common here? So look at here. look at minus gmm, it is common in all the terms, so take it common, take it as a common, so minus gmm is taken as common, so what will be left? 1 over r minus 1 over r1 plus 1 over r1 minus 1 over r2 plus 1 over r2 minus 1 over r3 up to 1 over rn minus 1 to 1 over rn. Okay, so I took minus gmm as a common. Okay, so look at these terms, minus 1 over r1 plus 1 over r1 minus 1 over 2 plus 1 over r2, so all these terms will be cancelled. So what will be left? So we will have minus gmm 1 over r minus 1 over rn. So this is the total work done from where to where? Look at here, look at the equation, from r to rn. This is the total work done from r to rn. Okay, now look at here, the total work done is from minus gmm 1 over r minus 1 over rn. This is the total work done from r to rn. So this total work done against the gravity is called gravitational potential energy. This total work done against the gravity is called gravitational potential energy. Okay, so this is called gravitational potential energy. But now, what is Rn? Rn is a last point within the gravity. So we want to perform a work which escape the body from the earth gravity, due to which the body can escape from the earth gravity. Look at here, look at the definition of gravitational potential energy. The definition is the work done on the body against the total gravitational field. So we want to perform a work against the total gravitational field. Total gravitational field. So what is the last limit of gravitational field? So wait a minute. Welcome back. Okay. So look at here, look at the diagram. So if we displace the body from r distance to rn, so this is called relative gravitational potential energy. Relative means which is compared between the 2 points, because it is comparing whether potential energy is maximum at this point or whether potential energy is maximum at this point. So it is the comparison between the 2 points. So from here to here, the gravitational potential energy is called the relative gravitational potential energy. Relative mean which is compared between the 2 points. But if someone wants to do work from Earth's surface to infinity, infinity means the total gravity. So if you want to perform a work against the total gravity, so what is the last limit of gravity? The last limit of gravity is infinite. So suppose the rn distance is at infinity. Suppose the rn distance is at infinity. So it means we want to throw out the ball from the infinity. Okay, now putting this value here, so it will be minus gmm 1 over r minus 1 over infinity. It means we perform work from r to infinity, from capital R to infinity. So it is the total work against the gravity. It is the total work against the gravity. So this is called absolute gravitational potential energy. This is called absolute gravitational potential energy. Why it is called absolute? Because it is work done from r to infinity, and 1 over infinity is equal to 0. Yes, 1 over infinity is equal to 0. So this is minus gmm divided by r. This is called absolute gravitational potential energy. Absolute gravitational potential energy means work done from Earth's surface up to infinity. Up to infinity means the against the total gravitational field. Okay. So this is the absolute gravitational potential energy. Another is absolute potential. What is absolute potential? Absolute potential is actually work done on the mass. Work done on the mass against the total gravity. And what is the total gravity against the field? It is absolute gravitational potential energy. What is the work done against the total gravitational field? Absolute potential energy. So this is absolute potential energy. And what is the value of absolute? The value of absolute is minus gmm divided by r divided by m. So mm will be cancelled. So this is the equation for absolute potential or gravitational potential. This is the so what is gravitational potential? Gravitational potential is work done on the mass. When suppose this pin is a mass. So if you perform some work on the mass against the gravity, so this agent is called a gravitational potential, but its energy is called gravitational potential energy. Okay, this is all about this topic. If you have any confusion, then you can ask it in comment section. Okay, thank you. Allah Hafiz.